So with the domain and the range, the domain is the set of x values. The range is the set of y values that you get from plugging in those x values or the output. Then we have what are called one-to-one functions. Okay, again, this is something that you would have talked about in Algebra 1, whether or not you recall that. So if each element in the function's range is paired with exactly one element in the domain, that is when we call something one-to-one. Okay, maybe you've heard for every input, there's exactly one output. And we can check this using something called the horizontal line test. Okay, and the horizontal line test, I just called it the HLT here. If you can draw a horizontal line through more than one point, okay, then it is not one-to-one. And then that's a way to shorthand writing it's not one-to-one. Okay, so we're going to identify the domain and range in each graph. And we're going to learn about a notation today that is called set builder notation. So in set builder notation, you make these fancy brackets. Okay, so I do like a little swoop, 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 swoop. Okay, if you're like, I cannot swoop, swoop, then what you can do is you can draw like a backwards 3 or a T and then a 3, that's fine. Okay? All right, so with the domain, the x values, you have to look from left to right. Okay, so the left side of the graph is this arrow, and it's going to keep going to the left, and it's going to keep doing that forever. So if it keeps going to the left with the x values, we say that it's going to negative infinity. So if it keeps going, if there's an arrow, okay, it is going up if you're looking at the y, but in terms of the x, it's going to the left. And then we have another arrow here, which means to the right, it keeps going on forever. We call that positive infinity. So when you have these two-sided arrows, your domain is all real numbers. That might be something you've heard before, but the way that we write all real numbers and set builder notation is a little bit different. So we're going to do our fancy bracket. And then these are the real numbers x. And then we have this line here. Okay, that line means such that. So this means all real numbers x such that x is an element in the real number set. And I know that's kind of a lot. Okay, when we practice it, it will become second nature. So the real number is a capital R with the line through it. Okay, so all real numbers is x such that it's an element in the real number set. Okay, and then for the range, we're going to look at the y's. So we have to look up and down because the y-axis is up and down. Okay, so for the y's, this arrow is going up, so it's going to positive infinity. This arrow is going down, so it's up. This is down. Okay, and so this is going to be all real numbers as well. So anytime it's a line, it's really just all real numbers for both. So y such that y is an element of the real number set. Okay, and that e, that element, is like this. Okay, so anytime it's a straight line, both of those are going to be all real numbers. All right, so for B, we're going to start again with the domain. Okay, so we're going to look left and we're going to look right. So on the left side, you have this arrow. Okay, that arrow is going to continue going up forever. So it's going to keep going to the left. So we say that that's going to negative infinity. And again, I know this is not easy. Okay, but on the left side, it is going to negative infinity. On the right side, it's going to positive infinity because it's going to keep going up. Okay, and so this is going to be all real numbers. Okay, now the range. This is not a straight line, so this one's going to be a little bit different. Okay, I just want you to find the lowest part of that graph and just put your finger on it. So on the graph, I want you to find the lowest value, put your finger on it. Okay, can anybody tell me what number that is that their finger's on? Yep, -2. Okay, so the lowest value is -2. Maybe tell me what the highest value is? Infinity. Infinity, great. Okay, so your lowest value, we're going to label as -2. Your highest value is infinity. Okay, which really isn't a number, it's just an idea, because infinity goes on forever. So if this is the lowest value and all the points are above, we write that as an inequality, which means we have those greater than equal to or less than equal to. So we're always going to start that with a y such that. And if all of them are above, do we use greater than equal to or less than equal to? If they're all above, yeah, greater than equal to, and then -2. All right, so based on this one, I want you guys to try part C. And then once you have an answer down, you can go ahead and check with one of the people right next to you to see if you guys got the same thing. All right, what are we thinking for the domain for C? What are we thinking? Yeah, all real numbers. So x such that x is an element of the real number set. Okay, what is a clue that it's gonna be all real numbers? Yep, you have both of these arrows here. Okay, which means it's going to the right. It's going infinity to the right. Okay, and then in terms of the x, it's a negative infinity because it's left. On the left side, it's going to keep going this way. Okay, for the x-axis. So it's all real numbers. So x such that x is an element of the real number set. Okay, and then just like we did here, we're just going to find that lowest value. Okay, so that lowest value is 1. Everything is above it. So if everything is above it, it's going to be just like this one. Yep, y is going to be greater than or equal to 1. Okay, so that one was very similar to part B. All right, I really think that is, that doing the domain and range is probably the hardest thing that we'll do today. This is going to be a little bit simpler when we get to our tables. So you have a table, the number of raffle tickets sold for the first 6 hours of a county fair. Define the domain and range of the function. So when you have a table, this first row here, that's going to be your input. That's going to be the domain. Okay, so that top row is your input, which leaves this bottom row is the range or your output. Okay, and we're going to define these in the set notation, but when you have all these numbers, your set notation can look a little bit different. So for your domain, you are just going to list the numbers. So use your set notation, and then it's 1, 2, 3, 4, 5, 6. All right, so based on that, go ahead, do your range. Okay, and those should be in numerical order. Okay, so you just have to make your fancy brackets and then list those in numerical order. So you have the 1, 2, 3, 4, 5, 6. Here you have 14, 18, 26, 36, 38, 54. Now, sometimes you might have numbers that repeat. You don't have to write them twice. Okay, if they occur more than once, you just have to write it once. Okay. All right, and then we're going to do then we're going to decide whether or not functions are one-to-one. So this is where you're going to use the horizontal line test. So use the HLT for these. Anytime it's one-to-one, you're going to use the HLT. Right? A lot of times I'll just use my writing utensil. So if I can hold it horizontally and it hits more than one point, like this, right? That means it's not one-to-one. The second one is a little bit tricky because to our eye, it could look like it's hitting more than one place. It's just it's curving up so small that it is going to be one-to-one. So it doesn't hit any place more than once. Okay, so if you drew a line, you'd only hit your graph one time. Okay, and the last one's a special case too, because if you draw a horizontal line, this is a horizontal line. It overlaps everything, so that means it's intersecting at all the points. So that is not one-to-one because it's intersecting all the points. Okay. All right. And then the next thing we're going to learn about today are continuous functions. So if it is a continuous function, It's a graph that has a line or a curve that's not broken. If it's discrete, the points are not connected. Okay, so discrete, they are not connected. If it's continuous, it has to have some type of unbroken curve or a line. Now they can be neither, and those consist of a mixture. So there are some isolated points and some connected lines. So based on those definitions, I want you to label which one of these is continuous, which one is discrete, and which one is neither. Which one is neither? And then I'll help you with the All right. For the first one, Brooklyn, what did you choose for that? Yes, it is continuous. Great. Okay, and then Regis, what did you decide for the second one? Great. Which only leaves one. And that last one is neither. Okay, so we are going to do the domain, okay, in set builder notation. And this one, there's actually two ways to write it, okay? So domain is X. What is the only X value in this graph? Only one. Yep, it's 3. Okay, so 1, 2, 3. That's the only X value that it goes through. Okay, so you can either write this as just 3 in parentheses. That's fine if it's just a number. Or the other way you might see it is X such that X is equal to 3. Okay, now the range, this is where we look up and down. Okay, so you can see I have an arrow, which means I'm going to infinity. I have a down arrow, which means I'm going to negative infinity. And anytime I have those, what's my range? Yep, it's all real numbers. So y such that y is an element in the real number set. Okay? All right, now for a discrete graph, this is new. We haven't done a domain for this one like this yet. Okay, so if you have just points, remember, these are the X values. So every point is an X and then a Y. So you just have to find all the X values. So for the X's, we have 2, we have 4, we have 3. All you have to do is write those in order. Okay, so write those in order from least to greatest. We have 2, 3, and 4. And then I know that some of you have already predicted what the range will be. The range is going to be the Y's. So again, just go ahead, put those in order from least to greatest. The Y's, the least one is always on the bottom because it goes down, up. Right? So -1, 1, and 3. Okay, and then for this last one, we have 2 different intervals. So this is going to be a little bit different. We're going to have to use some inequalities here. So for the x's, what we're going to do is find where these are on the x-axis. so let's go ahead and label this. So if I go 1, 2, 3, 4, this is at -4. If it's right on the axis, what is that at? 0. Okay, so what we're going to do is we're going to make an inequality with that one first, and then we're going to try the next one. So this is x such that, and then your inequality is going to be -4 is less than or equal to x, which is less than or equal to 0. That's the first part. Do any of you know why I'm using equal to instead of the just the less than? Because of the less.
Because it can be on that.
Yeah, it can be on that point. And how do you know that by looking at the graph? You guys remember about the points, they can be open or closed? So anytime it's closed, you'll have the equal to. Next week, we might have some, well, not next week, this year, we'll have some that do have open circles, and we'll start thinking about those differences. Okay, and then we have this other little guy here. So let's figure out what that's going to be. So again, we're trying to line that up with what's on the x. So if I line this up, I'm at 1. And then this is an arrow. The arrow is going down. So that means all of my values, the down is going to be for y. This means that all of my values for the x, it's just going to keep getting larger and larger. So it's really just going to infinity to the right. Okay, so the way that we're going to say that is all of these values for x are greater than or equal to 1. Okay, so all these points down here, if we correlate them to x values, they're getting larger and larger. Okay, and then we're going to switch gears for the range. So the range, we're going to start with the lowest value. Okay, so the lowest value is this arrow, which is -infinity. And then we're going to go up to the next point. So we're going to have to count to see where that is. So we go 1, 2, -3. Okay, so all of these values are below -3. So we're going to do y such that y is, and in this case, it's going to be less than or equal to -3. Or, and then I want you to see if you can write this one. So I want you to find the lower one, find the higher one, and see if you can write that in an inequality. Okay, if you're not really confident about that yet, just go ahead, you can just go ahead and label where they are on the graph on the side. Okay, so label the lowest one and then the highest one. All right, so we're going to just count here. 1, 2, which makes it -2. 1, 2 up, that makes it +2. And so the way that we write this is -2 is less than or equal to y, which is less than or equal to 2. Okay, and these are a little more complicated. We're going to work on that more next week. All right, I'm going to give you the rest of the time today to complete your homework, and then I'll come around with questions and help you with questions. Okay, and then if you finish this in class, then I want you to get a Chromebook and upload it